Right. Hi everyone. So, sekejap saya kena buka dekat Telegram dulu jap. Oh, salah. Nanti kalau saya tak buka, saya tak nampak awak punya komen. Sebab tu dia kena buka sekejap. Ya, boleh tak nampak terus. By next week we gonna finish chapter 9. Lepas tu kita boleh start dengan chapter 10 lah. Okay, done. Siap settle. Hai Adira. Adira kat Aisyah, tak tahu lah. Mana je lah kot. Boleh kot. Okay, so sekarang I think let us start. It's already 12:02, so let us start so that we can finish early and we can have our lunch after that. Okay, let's go. Sekejap, nak bagi full screen. Okay, done. Right, last time I stopped at example 2, so let us proceed with this. And once we finish with this, we're gonna proceed with the implicit differentiation. Okay, so given that y is equal to 3 plus 4x, multiply with e to the power of negative 2x, find dy over dx, and d2y over dx square, and then we need to show that d2y over dx square plus 4 dy over dx plus with 4y is equal to 0. Right, so basically what do you see over here? We have a multiplication between 3 plus 4x and e to the power of negative 2x. Therefore, for this one, we need to use a product. So one of them will become the u, another one will become the v, and then we're going to use the product rule u v prime plus v u prime to differentiate them. Okay, so let's go. Okay, so u is equal to 3 plus 4x, and then v prime is negative 2 e to the power of negative 2x, and then plus with, so this is u, v, so this is u, v prime plus v u prime. Okay, so this is v, this is u prime. Okay, so u is 3 plus 4x, v prime is negative 2, e to the power of negative 2x, u prime is equal to 4, v is e to the power of negative 2x. I think I told you guys to try and do this, right? Saya dah minta tolong buat kan, sebab tu saya keluar pop macam tu je. Okay, so now we factorize out negative 2 e to the power of negative 2x because we do have something in common for both thing. So I take out negative 2 e to the power of negative 2x. So we have 3 plus 4x here. And then for this one, since I already take out negative 2, then that means I have another negative 2 in. So we got 3 plus 4x minus with 2. So this is 1 plus 4x. Multiply with negative 2 e to the power of negative 2x. And then again, you do have something with multiplication. So in order to differentiate them again, you need to use another product rule. So one of them will become the u, another one will become the v. And then again, we're going to use the formula u v prime plus v u prime. Okay, so this is our u, negative 2 e to the power of negative 2x. Differentiating 1 plus 4x, so that is how you end up with 4. So this is u v prime plus, right, so v is 1 plus 4x, u prime, so we're going to bring down the power, differentiate the power, bring it down, times with negative 2. So that is how you end up with 4 e to the power of negative 4x. If you couldn't see, that means I have to write them down slowly. So d over dx, negative 2e negative 2x. If we have some constant, simply copy down the constant. So negative 2. Differentiate the exponent. So copy down the exponent e to the power of negative 2x. Ln of the base. And then don't forget to differentiate the power. So differentiate, we get negative 2. So negative 2 times negative 2, that is how you end up with 4e negative 2x. This one. And then, of course, we do see 4e negative 2x for both of them. So I factorize out 4e negative 2x. So I will be left with negative 2 here. And then over here, we are left with 1 plus 4x. So we got negative 2 plus 1 plus 4x. So if you simplify them, it will become 4e negative 2x multiplied with 4x minus 1. Hopefully not too fast. Okay, and then we need to prove that the second derivative of this is actually equal to 0. Okay, so take your second derivative as well as your first derivative as well as the y, substitute into the formula. So this is our second derivative, this is the first derivative, and this is our y. So substitute into the formula, and then don't forget you need to expand them because we need to simplify them. So expand them, it will give us 16x e to the power of negative 2x, negative 4e to the power of negative 2x. This one, expand them again. Don't forget this one need to times with 1 before you times with 4. And negative 2e negative 2x will be times with 4x before you times with 4. So times everything, and then you're going to end up with negative 8 e to the power of negative 2x, and then we will have negative 32x e negative 2x. So just in case you couldn't see y, so we got 4 times with negative 2e negative 2x times with 4x. So this is 8 times 4, so that is how you end up with 32x e negative 2x. And then we got 4 times with 3, and then times with e to the power of negative 2x. So we got 12 e negative 2x. And then 4 times with 4x times with e. So that is how you end up with 16x e negative x. And then simplify everything. You should be able to see that your answer is actually equal to 0. Okay, so that is our job. We want to prove they are equal to 0. Okay, so this one is quite long. We actually have one alternative for them, which is, okay, so let me show you the alternative part. Okay, so what do we have here? Once we differentiate them, we get negative 2, 3 plus 4x, e negative 2x plus 4, e negative 2x. And then this one over here, 3 plus 4x e to the power of negative 2x. This is actually our y. So we can replace them with negative 2y plus with 4 e to the power of negative 2x. So they're much more simple compared to the previous one. In the previous part, we do have quite a lot of things for the second derivative because we need to do another product rule. But for this one, since you already replaced this one with y, what do you have next is negative 2y. And differentiating negative 2y is simply negative 2 dy over dx. And then differentiating this, so differentiating 4e negative 2x. So gonna copy down the 4, copy down the exponent, ln of the base, ln e, and then we should differentiate the power negative 2. So that is how you end up with negative 8 e to the power of negative 2x. Okay. And then you can actually simplify them and it will become something like this. So dia macam kita main modify sikit lah. Kita modify sikit sampai kita dapat hasil apa. Okay, but this is alternative. Of course, if you cannot really see them, then it will be quite easy if you simply use this formula, substitute inside this formula, and then you can easily see on the right hand side, we are going to get 0. So kalau rasa macam payah sikit, then masuk dalam formula lah. Right, X. Yang ini sebab dah buat, so saya go laju sikit. X. Right, so today we are going to learn about the implicit differentiation. So what The explicit and implicit. So normally, so far in our lecture, we have like 3 lectures. And so far in our lectures, we only learn how to differentiate something called the explicit function. So in explicit, I will have y as the subject. And then I will differentiate everything on the right hand side. On the left hand side, that will simply give me dy over dx. For implicit differentiation, it simply means that I cannot write down y as my subject. So for example, over here, we cannot have y as the subject because we're going to have something in terms of y. We still have something in terms of y. So we cannot have y as the subject either for each of these. So we cannot differentiate them directly just like what we did in explicit. So dia ada style dia sikit lah macam mana kita nak differentiate. Okay, so basically, today we are going to find the first and the second derivative implicitly. So we're gonna do the derivative for the implicit function. Okay, never mind. Right, so to differentiate an implicit function, we're gonna write them down as explicitly. So for example, if let's say we want to differentiate y with respect to x. So what does it mean? We want to differentiate with respect to x, so it should be d over dx. The function that we want to differentiate, it will be on the right hand side. So this is d over dx of y. So the answer for this is simply dy over dx. If let's say you want to differentiate y to the power of n with respect to x, then differentiating d over dx of y to the power of n, since the variable over here is y, we're going to use something called the chain rule. So we're going to differentiate the y with respect to y first, and then we're going to multiply them with dy over dx. Okay, so differentiating y to the power of n with respect to y, so that is simply a basic power rule. So you're going to bring the power down, copy down the function, deduct 1 to the power, and then differentiate y, we are going to get 1. So that is how you end up with n, y to the power of n minus 1, multiply with dy over dx. Okay, so that means if let's say we want to differentiate, let's say I give you y squared. Okay, so we got different variable over here. So if we have different variable, do make sure to use the chain rule for them first. Change it into this variable. So we are going to get d over dy of y square multiply with dy over dx. So that if you do cancel out your dy, you should be able to see you are going to get back d over dx of y square. And then of course, we're going to differentiate y square just like usual. So this is 2y dy over dx. Okay, so perhaps we should try another one. So d over dx, let's say y to the power of 3. Just a simple example for you first. Okay, so again, this is different variable. So d over dy of y cubed multiply with dy over dx. Check your chain rule, make sure you do get d over dx. So they are equal, so we are going to get d over dx of y cubed. Okay, so now differentiating y cubed, so this is 3y square. And then for this function, you simply need to copy down. So you're going to multiply with dy over dx. Okay, so that is what we mean by differentiating them implicitly. Next. Okay, so for example, if let's say I give you y square plus with 4x equal to 6x square, and then I ask you to differentiate them and get what is dy over dx. Okay, so how do we do this? Basically, if we want to get dy over dx, that means I should differentiate everything with respect to x. So write this back, but please do make sure to add d over dx on the left hand side and d over dx on the right hand side. Since we have a plus, so that means I can actually separate them into 2. So I will have d over dx of y square plus d over dx of 4x, and this is d over dx of 6x squared. Okay, so 4x. Right, so this is the same variable, so that is okay. This is also the same variable, that is okay. This one, different variable, so this is not okay. We're gonna use the chain rule for them. Okay, so we have to differentiate y square with respect to x. So we got different variable. So this is d over dy of y square multiply with dy over dx. And then of course you should differentiate y square. So differentiating y square, that is simply 2y. And then we're gonna multiply with dy over dx. Okay, so I'm gonna write this down. Oops. Tertutup pula. Sekejap saya tulis lagi sekali. Okay, so this is d over dx of y square plus d over dx of 4x. Oops. Equal to d over dx of 6x square. Okay, so differentiating y square, so this is 2y dy over dx. Differentiate 4x, that is equal to 4. Differentiate 6x square, it will become 12x. And then of course you can have your dy over dx as the subject now. So bring the 4 to the right hand side, divide everything by 2y. You are going to get dy over dx as the subject. Okay, so now let us do the first example. So just now that is still not the first example. So let us go to the first example. Find dy over dx in terms of x and y if y cubed plus 6x equal to x squared. So I think I'll do A and then you guys will do B. Okay, so A, we got y cubed plus 6x equal to x squared. So what do? Is that we're going to write d over dx for each of the term. So d over dx of y cubed plus d over dx of 6x equal to d over dx of x squared. And then of course we're going to see each of them and then see do we need to use chain rule or not. Okay, so this one different variable, therefore I need to use a chain rule. This is the same variable, so I can actually differentiate them right away. So that one will give me 6. And then this one differentiating x squared, same variable, so this is 2x. Right, so now differentiating different variable, chain rule, so this is d over dy of y cubed multiply with dy over dx. Okay, so differentiating y cubed, so this is 3y square multiply with dy over dx. And then since the question asks for dy over dx, we should have dy over dx as the subject. Therefore, dy over dx is equal to 2x minus with 6 and then divide everything by 3y square. Or you can actually factorize the 2 out. So 2x minus 3 over 3y square, and this is dy over dx. Okay, so do be extra careful with the term that you add over here. If we are differentiating with respect to x, therefore we need to write down d over dx. If we are differentiating with respect to y, then it's supposed to be d over dy. Differentiating with respect to, let's say, z, then this is d over dz, and so on. I'm sure you get the idea, right? Okay, so I have done A, and I think it's your turn to do B. But I'll give you one hint first. Okay, so this is d over dx of x ln y equal to d over dx e to x. The right hand side, this is quite okay. I'm sure you know how to do this. But on the left hand side, you got to be extra careful because we have x multiply with ln x. Therefore, for this one, you need to use something called the product rule. So you need to use the product rule for this. So that is my hint. Do make sure to use the product rule. Okay, so I'll give you around 3 minutes and then let us see will you get your dy over dx or not. So 3 minutes starting from now until 12:24 p.m. not a.m. Okay, so it's already 12:24. So tak apa, kita tengok. Okay, so like I told you before, we are going to use the product rule. So u is equal to x, v is equal to ln of y. Okay, so now we're going to differentiate them. So u prime is equal to 1, but this v prime, you should be extra careful because we are differentiating ln of y. This is different variable, therefore, we should have d over dy of ln y and then times them with dy over dx. Differentiating ln y, that one will become 1 over y dy over dx. And then of course we're going to use the product rule. So the product rule is u v prime plus v u prime. Okay, so the value for this. Okay, so v u v prime. So we are going to get x multiplied with 1 over y dy over dx and then plus, so vu prime, so we are going to get ln of y equal to, so differentiating exponent, we're going to copy down the exponent, ln of the base, so ln of the base, ln e, differentiate the power, so we are going to have 2. So this is 2e2x and we have x over y dy over dx plus with ln of y equal to 2e2x. And then in order to have dy over dx as the subject, so I'm going to deduct with ln y and then we're going to multiply them with y, divide everything by x. Or it will look like something like this. So dy over dx is equal to 2e2x minus with ln y and then divide everything with x over y. So since you divide with a fraction, it will be the reciprocal. So y 2e2x minus with ln y divided everything with x. Okay, so ini yang saya tulis. Kalau nak tengok jalan kerja yang ringkas sikit kat sini lah. Okay, so basically they differentiate this straight away. So normally, we do differentiate them straight away, but I do find it will be much more easier if I start with the step of d over dx first. Sebab tu kalau pasal step saya memang akan ada d over dx dulu. Normally for me, I find it very easier for me because I can see whether I'm differentiating with respect to x or if I'm differentiating with respect to y. Okay, now let us go to the next one. So the second order derivative. So now we want to find d2y over dx square or f double prime of x. So that is the second order. Basically, from your dy over dx, you just need to differentiate them again. So we already have dy over dx before this. You simply differentiate this again with respect to x. So it will become d2y over dx square then. Right, so example 2, given the equation of the curve is 3x squared plus 4y squared equal to 15xy minus with 6, find the value of dy over dx and d2y over dx squared at 0.13. Okay, so we need to know what is dy over dx first. So we have to differentiate this to get dy over dx, and then we have to differentiate them again to get the second derivative. But after that, we need to calculate the value x equal to 1, y equal to 3, and find out what is the value for dy over dx and d2y over dx square. Okay, so let us find the first derivative. Suddenly, terlupa nak letak animation. Okay, never mind. So we got 3x squared plus 4y squared equal to 15xy minus with 6. So I'm doing d over dx for everything. So I will have d over dx of 3x squared plus. So since I have a plus, so that is how I know I can actually separate them. So this is d over dx of 4y squared. This is a multiplication, don't separate them. So this is d over dx of 15xy minus d over dx of 6. Okay, so now we should try to differentiate one by one. So differentiating 3x squared, this is similar variable, so you can quickly differentiate them. This is actually equal to 6x. Right, so for this one over here, we got different variable, therefore we need to use a chain rule. So this is d over dy of 4y squared multiply with dy over dx. And then differentiating 4y squared, that is 8y dy over dx. Right, so now over here we got 15xy. So this is actually something with multiplication. So you need to use a product rule for them. So u will become 15x, v will become y. So u prime, so differentiating 15x, it will become 15. V prime, differentiate y. This one will simply give you dy over dx. And then use the product rule for them. So u v prime plus v u prime. Okay, so what do we have next is... Tak nampak dah, hilang dah. Okay, never mind. I write them down for you. So this is 6x plus with 8y dy over dx. And this is equal to, so u v prime. So we got 15x dy over dx plus with 15y. And differentiating 6, I'm sure you know now, differentiating a constant, it should become 0. Okay, so now what happened next is that you're going to bring dy over dx to the left hand side. So that is how you end up with 8y minus with 15x dy over dx. The term without dy over dx, for example, this one, you should bring them to the right hand side. So that is how you end up with 15y minus with 6x. So all the dy over dx bring to the left hand side. We're going to collect dy over dx. The term without dy over dx will go to the right hand side. And then now we're going to substitute x equal to 1, y equal to 3. Okay, so substitute x equal to 1, y equal to 3. We are going to get 8 times 3 minus with 15 times 1 dy over dx equal to 15 times 3 minus 6 times 1. Okay, so do make sure to have dy over dx as the subject. So we are going to get dy over dx is actually equal to 13 over 3. So we're going to substitute the value of x and y, and then we're going to see what is the value of dy over dx. Okay, so now we should differentiate this again to get the second derivative. Not this one, but the previous one. This one. So I have to differentiate this again to get the second derivative. So let's go. Okay, so that is the function. 8y minus 15x dy over dx is equal to 15y minus 6x. So now I'm going to differentiate them again with respect to x. So it will be d over dx of 18y minus 15x multiply with dy over dx equal to d over dx of 15y minus d over dx of 6x. Okay, so now be extra careful. Alright, so I'm differentiating something like this. So 8y minus 15x times with dy over dx. Like what I said times. So this is definitely a product rule. So you're going to let u equal to 8y minus 15x. And then the v will become dy over dx. Okay, so u prime differentiating 8y. So this is 8 dy over dx. We are using some chain rule over here. Differentiating negative 15x. So that is negative 15. V prime differentiating dy over dx. That will be the second derivative. So d2y over dx square. Okay, so for this one, if let's say this one you couldn't see how, we are using some chain rule over here. So this is d over dy of 15y multiply with dy over dx. So that is how you get dy over dx times with 15. So 15 dy over dx. So similar thing happened over here. So that is why I get 8 dy over dx. Differentiating 6x. This one, be careful. Differentiating 6x, you are supposed to get 6. Okay, so now I'm going to write them. So u v prime, v u prime. Okay, so u v prime plus v u prime. And then, of course, this is equal to the right-hand side. So 15 dy over dx minus with 6. Okay, so I'm going to simplify them a little bit because we want to know what is the value of d2y over dx square at x equal to 1, y equal to 3. So I'm going to expand them a little bit. So this one times with this and this times with this. So what do I have is 18y minus 15x d2y over dx square. So this one, be careful when you times them, it's not become d2y, you know, it become dy over dx square minus 30 dy over dx plus 6 equal to 0. So this one comes from here. So I bring this one to the left hand side and then I simplify them. Okay, so now we're going to substitute the value of dy over dx as well as the value for x and y. And then we're going to find out what is the value of d2y over dx squared. Okay, so again, I repeat what happened over here. After I write down d over dx, I see this is some product. So that is why I'm using some product rule. So u is 8y minus 15x, v is dy over dx. Differentiating v, it will become the second derivative, but you need to be extra careful with the u prime. Because over here, when we differentiate 8y with respect to x, we are using different variable. So you need to use a chain rule for this. So it will become 8 dy over dx. Differentiating 15x, it will become 15. Differentiating 15y, again, we got different variable over here. So use another chain rule for them. So it will become 15 dy over dx. Differentiating 6x, it will become 6. Expand and bring everything to the left hand side. So you will be left with 8y minus 15x d2y over dx square plus 8 dy over dx square minus 30 dy over dx plus 6 equal to 0. So now substitute the value of dy over dx, substitute the value of y, substitute the value of x, and then we're going to get the value for the second derivative. Okay, so dy over dx is 13 over 3. So I already substitute into here. dy over dx is 13 over 3. So the value of my second derivative, so d2y over dx square is actually equal to negative of 236 over 81. So this is the value of the second derivative. Okay, so let us proceed with example 3. Okay, so given that xy is equal to sine 3x, show that x d2y over dx square plus 2 dy over dx plus 9xy is actually equal to 0. Okay, so do check first. In your denominator, you have x, so that means we should differentiate everything with respect to x. So that means don't forget you need to write down d over dx of xy equal to d over dx of sine 3x. And then of course we're going to differentiate them one by one and then get the second derivative, substitute the formula, prove that they are equal to 0. Okay, so for this question, I think it will be nice for you to practice. So I'll give you around 5 minutes. Try to prove this one. Try to prove this statement. Okay, so we're going to start again at 12:43. Pastikan semua orang cuba tau. Dia benda-benda macam ni dia kena cuba sendiri. Kalau tak cuba, tak nampak dekat mana. Oh, saya lupa nak cakap Farah. Hai, lupa. Tadi cakap dekat Aisyah je. Lupa pula. Sedar tak sedar ni dah minggu 16. Lagi 2 minggu dah nak habis. Bersediakah kalian untuk exam? Are you guys prepared for your exam? So kena start prepare untuk exam semua orang. Kalau yang rasa macam tak start study lagi tu, kena start dah lah. Sebab lagi 2 minggu nak habis kelas. Lepas tu kita akan buat study week kan. Lepas tu baru exam. Almost finish the first semester. And then we have the second semester. And then finish. Tengah prepare untuk exam ah. Good. Adakah sem depan kena buat live juga? Kuliah tak tahulah. Tapi saya rasa kan bila dah lama buat live yang macam ni dengan ada laptop je, tiba-tiba je kalau buat dekat dewan kuliah mesti dia rasa macam panic attack sikit. By the way, bukan bot. Tahu tak baru-baru ni saya dapat spam berapa dekat video yang minggu lepas. Berapa spam 4 komen spam kot. 4 ke 5 spam yang macam saya kena letak ni. Report spam. Bukan hari tu dah tukar nama ke? Macam mana boleh kembali ke nama yang lama? Ke tak tukar channel? So korang pun kalau tiba-tiba nampak komen yang macam pelik-pelik ke apa tu, jangan lupa bagi tahu lah. Kadang-kadang tak perasan. Saya tak perasan dalam notification tu. So, sebab tu dia boleh keluar benda yang pelik-pelik lah. Ya Allah, dia seorang ada 3 akaun. Melampau. 3 akaun YouTube. Nak buat apa lah kat ni banyak sangat. Okay, tak apa. Right, so now let me show you how to do this question. Okay, so xy equal to sin 3x. So we're going to differentiate left hand side, right hand side. And like I told you before, I prefer to write this one down so that I know whether I'm differentiating with respect to x or if I'm differentiating with respect to y. Okay, so now we got a multiplication between x and y. Therefore, we need to use a product rule for this. So u is equal to x, v is equal to y. So u prime is equal to 1, v prime is equal to dy over dx. Okay, and then we're going to use the product rule. So this is u v prime plus v u prime. So we are going to get x dy over dx plus with y equal to, okay, so now we differentiate sign. So we differentiate sign, we are going to get cos. So cos of 3x, and then you differentiate 3x, you are going to get 3. So we have x dy over dx plus y equal to 3 cos of 3x. Okay, so once we have this, let us differentiate again to get the second derivative. Okay, so now differentiate to get the second derivative. So I will do d over dx of x dy over dx plus d over dx of y equal to d over dx of 3 cos 3x. So normally for me, if from here and I want to calculate the second derivative, normally for me, I don't write dy over dx as the subject. Because I do find that doing product rule is much more easier for me of course, untuk saya. I prefer to use a product rule instead of a quotient rule. So that means if I don't have to write down dy over dx as the subject, then I prefer to use the product rule straight away. Kecuali saya terpaksa tulis dy over dx sebagai subjek. Kalau tak, biasanya saya akan terus ambil dan differentiate dia lagi sekali untuk dapatkan second derivative. Tapi tak kisahlah, kalau nak buat dy over dx sebagai subjek pun boleh. Tapi quotient rule tu biasanya leceh sikit. Okay, so now enough with that. So d over dx, x dy over dx plus d over dx of y, differentiating 3 cos 3x. Okay, so I'm sure you should be able to see here. This is a product between x and dy over dx. So again, another product rule. So u is equal to x, v is dy over dx. So u prime is equal to 1, v prime is d2y over dx square. Therefore, you're going to use the formula for them, u v prime plus v u prime. This one, differentiating d over dx of y, this is supposed to get dy over dx. And for this one, this is simply the same variable, so you're gonna bring the constant out first, differentiate the cos, it will become negative sine of 3x. Differentiate 3x, we are going to get 3. Okay, so let me combine everything into one line. Sebab yang ni saya buat sikit-sikit kan. So let me combine everything into one line. So it will become x d2y over dx square plus dy over dx plus dy over dx. And this is actually equal to negative 9 sine of 3x. So this actually comes from the product rule that we have before this. So x d2y over dx square plus dy over dx plus dy over dx equal to negative 9 sine of 3x. Okay, and then of course I'm going to bring everything to the left hand side. So we have x d2y over dx square plus with 2 dy over dx plus with 9 sine of 3x, and this is equal to 0. Okay, so now if you go back to the question, let us go back to the question. So we got xy is equal to sine of 3x. So xy is equal to sine of 3x. So this one we can actually replace them with x, y. So that is how you end up with x d2y over dx square plus 2 dy over dx plus 9 xy equal to 0. Proven. Done. Semua orang. Oh, tiba-tiba dah tukar account. Okay. Next. Let us proceed with the last question for today. Example 4. The curve x square plus y square equal to kx plus 2y passes through the point 1 and negative 1. So I know it passes through the point x equal to 1, y equal to negative 1. Oops, y equal to negative 1. Okay, so now determine the value of the constant k. Okay, so that means I can substitute x with 1, y with negative 1. And since they must be equal, left hand side and right hand side, I can actually compare left hand side and right hand side to get the value of k. So that is how we determine the value of the constant k. For b, show that 3y square minus 2 d2y over dx square plus 6y dy over dx square plus 6x equal to 0. So for this one, I should differentiate with respect to x. And until the second derivative, of course, because we have d2y over here. Okay, so let me do for a first. So substitute x equal to 1, y equal to negative 1, and let us calculate what is the value of k. Okay, so substitute x, substitute y, substitute x, substitute y. So at point 1, negative 1, so x will be 1, y will be negative 1, so substitute in. So we are going to get 1 cube plus negative 1 cube equal to k times 1 plus with 2 times negative 1. And then negative 1 cube, simplify them, this is negative 1. 1 cube, this is 1, k times 1, this is k, 2 times negative 1, this is negative 2. So what do you have is k minus 2 equal to 0. So that will mean that k is simply equal to 2. Okay, so done with this, let us proceed with the implicit differentiation. Actually, implicit is quite fun. After quite a while, once you get the hang of it, dia macam okay lah. Dia bila kita rasa macam dah selesa tu, dia macam kacang dia. Okay, so let us differentiate x cube, y cube, 2x and 2y. So we already substitute the value of k. Do you realize here? I substitute the value of k. So we're gonna differentiate x cubed, differentiate y cubed, differentiate 2x, differentiate 2y. Okay, so this is the same variable, so we can actually differentiate them straight away. This is different variable, therefore we need to use a chain rule for them. So this is d over dy of y cubed multiply with dy over dx. So this is the same variable, so that is okay. This one, this is not okay. We got different variables, so another chain rule for them. So this is d over dy of 2y multiply with dy over dx. Okay, so this one we're gonna simply differentiate x cubed, so it will become 3x squared. Differentiate y cubed with respect to y, so this is 3y squared dy over dx. Differentiating to x, we are going to get 2. Differentiating to y, so this is 2 dy over dx. Okay, so now we got 3x squared, 3y squared dy over dx equal to 2 plus 2 dy over dx. Okay, so now I'm gonna differentiate this again because we want to get the second derivative. But before that, if you want to, you can actually bring this to the left hand side before we so we can actually simplify them first before we differentiate them. Okay, so you can have something like 3y squared minus 2 dy over dx equal to 2 minus 3x squared. So you can actually do this first. Okay, so now I'm going to differentiate this to get the second derivative. So it will be d over dx of 3y squared minus 2 dy over dx equal to d over dx of 2 minus 3x squared. Okay, so I'm sure on the right hand side, you should be able to see this is the same variable. So this is okay. We can actually directly differentiate them. But on the left hand side, this one, we have a multiplication between 3y squared minus 2 times with dy over dx. Therefore, in order to differentiate this, we need to use sum product rule. So u will become 3y squared minus 2. V will become dy over dx. Okay, so differentiating 3y squared. So this one, we need to use a chain rule for them. So this is d over dy of 3y squared multiply with dy over dx. Differentiating 2, it will become 0. Okay, so now differentiating 3y squared. So this is 6y dy over dx. So v is equal to dy over dx. V prime is d2y over dx square. And then we're going to use the product rule for them. U v prime plus v u prime. Tertutup sudah. Okay, so u times with v prime. So we are going to get 3y square minus 2 d2y over dx square plus v u prime. So we are going to get dy over dx multiply with 6y dy over dx equal to negative 6x. So on the right hand side, if you do differentiate them, you are going to get negative 6x. Okay, so what happened next? We are going to simplify them a little bit. Okay, so this one we got dy over dx times with dy over dx. So that is how you end up with dy over dx square. So 6y dy over dx square, and this is equal to negative 6x. Okay, and then we're gonna bring everything to the left hand side. So instead of having a negative of 6x, bring it to the left hand side, we are going to get positive 6x. So 3y square minus 2, d2y over dx square plus 6y dy over dx square plus 6x is actually equal to 0. And then that is what we want to prove. So prevention. Okay, so basically for implicit differentiation, the thing that you need to do is something called the chain rule. So do make sure, firstly, read the question carefully. You must make sure you are differentiating with respect to what? So if you are differentiating with respect to x, do make sure to write down d over dx for everything. So for each term, kena letak lah kalau, oops, nanti kalau ni pula, d over dx, yang lagi satu. Kalau ada tambah, boleh asingkan. If you have multiplication, then that one will stay inside here. Okay, so if you have multiplication inside here, you need to use sum product tool. If let's say you have different variable for this one, different variable, then you need to use a chain tool. Chain tool, product tool. And I think you will survive implicit differentiation. Okay, so I think that's all for today's lecture. So we have finished implicit differentiation. So next week, first hour, we're going to do parametric differentiation, and then I will start with chapter 10. So perhaps for next week, I'm going to take 1 hour extra, or perhaps not, but we want to finish chapter 10 by next week. Okay, that's all for today. Thank you, class. I'll see you guys whenever I see you. Goodbye. Have a nice lunch. Bye bye, everyone.